Alright, in this video I'm going to talk about continuity of a function and one-sided limit. Do you remember that when I introduced the limit of a function, if you want to find the limit of a function at the point A, what you do is you look at the height of the function left to A, and which is called the left limit, right? And height of the function right to A but very close to A is called the right limit. What is the notation for the left limit? The notation is limit x tends to A superscript minus and fx, right? And the right limit is limit x tends to A plus the superscript plus fx. It just tells you the left side or the right side of the limit. But if you are asked to find out the limit, left limit or the right limit, we do exactly the same way what we did to find out just a limit. What you do, you plug in that A into the x. Plug in the A into the x for both cases, okay? And to find out the functional value, also, you plug in A. You replace x by A and then find out. But one of the difference between finding the limit and the functional value is the function in the functional value you just plug in A. You don't simplify the function. You just replace x by A right away before you simplify it. But when you do the left limit and the right limit or the limit, you simplify first and then plug in the limit. I mean, you can try plugging in the limit at the beginning, and then if you get 0 over 0 or any kind of absurd form, then you can simplify and plug in back. But for the functional value, you plug in right away. For functional value, no need to simplify. To find out the limits, you may need to simplify. Sometimes the function will be already in the simplified form, so you don't have to simplify. But sometimes you need to simplify and then plug in the limits, okay? In this example, I am just looking at the graph and finding the limit. From the left, when you get close to A, the height looks like almost L, right? From the right, when you get close to A, the height is almost look like L. And also at A, the functional value, meaning the height of the function at A is also L. So here, the left limit and the right limit and the functional value, all of them are equal. So if a function has these three things equal, we call the function is continuous at that point A. Okay, so what is the definition of the continuity of the function? Is if the left limit limit x tends to if the left limit, that means limit x tends to A minus fx, is equals to the right limit, limit x tends to A plus the fx, is equals to the functional value at the point A, then we call fx is continuous at x equals to A. That's what we call, okay? If the left limit is equals to the right limit is equals to the functional value, and make sure that those limits and the functional value are finite, okay? They must be finite. Then we call that the function is continuous at x equals to A. You can look at from here to the function is continuous. There is no break, right? But mathematically, we don't look at the break or not. We don't draw the graph. But what we do usually is we can tell whether the left limit is equals to the right limit is equals to the functional value or not. And then we can decide whether the function is continuous or not. Let us look at this example, okay? On this example, find limit x tends to 2 minus fx. If you go to 2 from the left side, what is the height? It looks like the height is almost equals to 3, right? So it will be 3. How about limit x tends to 2 plus fx? If you go to 2 from the right side, okay, the height is almost equals to 3. This is also 3. And what is the functional value at 2? At 2, the height is actually 3. Since these three are equal, then the limit exists, okay? So for the limit existence, you need the left limit and the right limit equal. For the continuity, we need all these three things equal. So the limit exists, yes. What is the limit? The left limit and the right limit are equal to 3. So the limit is 3. You see that? Is the function fx continuous at x equals to 2? Since the left limit, right limit and the functional value are equal, the answer is yes. If the left limit, right limit, and the functional value are equal, then we call the function is continuous at that point. Okay, let us look at another example. Here, this is that graph of the function is in the green. Okay, at -2, we have -2, -2, but you see that at that point there is a open circle. There is an open circle. That -2, -2 is an open circle. Okay. Now look at that. Is the left limit? What is the left limit? We are going to -2 from the left side. Okay, right here. So it looks like the height is almost equals to -2, right? How about from the right side? If you go to the -2 from the right side, the height is almost equal to -2 again. How about the f at -2? Meaning, what is the height of the function at -2? Since it is the open circle, okay, does not exist, dne. So the functional value does not exist. How about the limit? Do you think the limit exists? The limit exists because the left side and the right side are equal. So the answer is yes. And what is the limit? Since these are both of the heights from the left and right are equals to -2. So the limit is -2, but the function is not continuous. Why? Because the limits, the left limit and right limit and the functional value are not equal. So the answer is no. Okay, let us look at this example. The graph is like this. From -1 and left, the height is -1, right? It is below. From -1 and from right to the -1, at -1 the height is -1, but right to -1 the height is +2, right? What is the left limit for this function? It is -1, right? The height towards the left of -1 is -1. What is the right limit of at -1? Is from, if you go to the -1 from the right, it looks like the height is almost equals to +2. So actually it is equals to +2. So the limit are not equal. You see that? Limit are not equal. How about the functional value? What do you think? To look at the height at -1, you look at -1 here because there is a closed circle, right? So at -1 is defined on this function. So anything right to -1 is defined on that function. So it is -1 as well. Do you think the limit exists? No. Right? The limit does not exist because the left limit and the right limit are not equal. How about the continuity? No, because the limit does not exist. Also the functional value is not equal to the left limit and right limit. So the answer is no. So from this you can say that if a function is continuous, then all these three quantities must be equal, right? All these three quantities must be equal if the function is continuous. But if the limit exists, the function may or may not be continuous. In this example, the limit exists, but the function is not continuous. Okay. On this example, the limit exists and function is continuous. Here, the limit exists, but the function is not continuous. Here, limit does not exist, so function is not continuous. From here, you can say that if a function does not have a limit at a point, then the function is not continuous at that point. Okay. Now let us do one more example on how to find out the right limit here. So again, to find out the limit, you need to simplify first. If you plug in right away, you will get 9 over x plus 0. That is 9 over x minus 9 over x is 0 over, if you plug in that 0, 0 over 0. So that's not the answer. So we need to simplify first. So what you do is you make the same denominator on the top, or you combine these two fractions. Okay. So what you do is limit delta x tends to 0 plus. Okay. So so what is the product of the denominator of the top function? X times x plus delta x. So what you do the cross multiplication like that, right? So it is 9x minus 9 times x plus delta x, and then divide by delta x there, right? That whole divide thing is here. Okay. So how do you simplify that? On the top, you can write 9x minus 9x minus 9 delta x. You see that? Divide by x times x plus delta x, and then divide by delta x there, right? So you can cancel out that a positive 9x and negative 9x. And if you want to simplify this fraction, there is like one fraction on the top and another fraction at the bottom. That bottom fraction has 1 in the denominator. So what you write is limit delta x tends to 0 plus, right? And that is negative 9 delta x over x times x plus delta x times times 1 over delta x. You see that? Because when you write the simplified form of the two fractions, you write the top fraction times the reciprocal of the bottom fraction. Okay, now you cancel out delta x and delta x. What is left is negative 9 over limit delta x tends to 0 plus, right, negative 9 over x times x plus delta x. You see that? Although there is 0 plus, basically it is 0, but it is saying from the right side. So basically you plug in 0 there. Limit, it is same as delta x tends to 0, negative 9 over x times x plus delta x. Now you plug in that 0 plus or 0, whatever you want to say, but this is basically 0. So you plug in 0 here. So what you get is negative 9 over x squared. That's what you get. And again, after you plug in the limit, you don't need to write limit again. Okay, after you replace delta x by 0, you don't need to write the limit delta x tends to 0 again. So this is the final answer. So the limit here is negative 9 over x squared.